Welcome to MVIF Conversations, the podcast.
Hello, everyone, and welcome to another episode of MVIF Conversations, the podcast. I'm Christina.
I'm Svetlana.
And today we are thrilled to welcome Professor Alexandre Soares Rosado. Alexandre Soares Rosado. Professor Rosado is a microbial ecologist and Professor of Bioscience at KAUST, the King Abdullah University of Science and Technology. In the Microbial Ecogenomics and Biotechnology Lab, Professor Rosado investigates microbial diversity and function, from extreme environments to host-associated systems, to develop microbiome-based solutions for ecosystem resilience, human health, and biotechnological innovation on Earth and in space.
Hey, so welcome to the podcast. And it's great to have you here.
Okay, thank you so much for having me. It's a great pleasure to be here today with you guys.
Thank you. So, prior to joining KAUST, you were a full professor at the Federal University of Rio de Janeiro in Brazil and a visiting professor at UC Davis in the USA. So, we know microbes are everywhere, but apparently so are microbiologists, as you. Can you tell us what drove you to study microbes in the first place? And was the pursuit of extremophiles that led you to KAUST, since there are so many interesting systems in your current location? So can you tell us more about it?
Yeah, sure. Well, actually, my first extreme ecosystem was Antarctica in North Saudi Arabia. But going back to the first question, I started very broadly in biology when I started studying biological science. So I was really fascinated by everything, actually, when you think about biological science. So my first option, actually, I was planning to become a zoologist, so this was my first thing. So during the undergrad course, I became fascinated by botany and biochemistry and so on. And right after my first class of microbiology, and there was a very inspiring teacher of microbiology at the same time, in that time, I was sure that that was my path, that was my call. And so I really become truly passionate about microbes and microbiology and all those things. And the idea stayed with me, they are everywhere. They are so tiny. At the same time, they can cause a huge impact in a global scale. So they are performing all the most important biogeochemical process and health and ecosystem health, human health. So it's really something that is really easy to be passionate about. And I followed that passion for microbiology. So I went through a master's in microbiology, and after that my PhD in microbiology as well from Federal University of Rio de Janeiro, and a huge piece of my PhD in the Netherlands, actually in Wageningen University. And that was fascinating. I went back to Brazil. I start working on several different Brazilian ecosystems, but my passion for extreme environments was really strong because they are unique. I mean, they can perform well, metabolically well in ecosystems that are really extreme. And so I start working on Antarctica, and I still have projects ongoing in Antarctic ecosystem. And this is going now for almost 20 years now in Antarctica. And 5 years ago, I actually moved to KAUST in Saudi Arabia. And was, Saudi Arabia is a paradise when you think about extreme environments, because we have deserts. We have not only one desert, we have several different kind of deserts. So we have rock deserts, we have, a sandy desert. It's fascinating. We have volcanoes over here. We have more than 2,000 volcanoes in Saudi Arabia. and they are quite unique. We have snow. That is something that most of people doesn't know. I didn't know before joining CAUS.
You wouldn't think.
Yeah, we don't think about this, yeah. But when we go to the north part of Saudi Arabia, actually there are a lot of snow during the winter time, so they can. It's really interesting. Hydrothermal vents in the Red Sea, hot springs. So a lot of unknown, actually, barely touched by scientists, different ecosystems here. So this is why I started studying those wonderful places in Saudi Arabia.
It's like a researcher's playground.
Sounds like that.
So we're going to talk a bit more later on about the extremophiles. But one thing that I saw from your website, from your lab's website, was the phrase, individually we are one drop, together we are an ocean, which I found quite inspiring. Do you believe that if we as researchers work together with a common goal, could we reverse or minimize the impact of global warming? Could we address major challenges if we all work together?
Definitely. I think collaboration is absolutely essential when you think about collaboration. I mean, we can do nothing without collaboration. Especially when we think about big planetary challenges that we are facing nowadays. And so this is not a local problem anymore. So this is, we are talking about system level problems. I mean, it's a huge thing. And microbial processes themselves are interconnected. This is what I learned during my time studying microbiology. And they are interconnected across ecosystems and across the planet. And when I think about this, it's clear that no single lab can solve planetary problem. And we know that competition has, its role when you think about excellence, and it pushes us to be better. But collaboration and not competition is what permits us to integrate, knowledge across disciplines and scales, and also across scales. So it's a huge thing. It's collaboration. That's the main golden word that we need to use nowadays. And microbes, they don't respect borders.
That's true.
Yeah, and our science and our scientists shouldn't either respect borders. I know there are some geopolitical issues sometimes, but talking about science and about humanity, that's how it should be. Science is science, and we need to move as humans and to learn about our planet. And at this point, I think collaboration is not idealism anymore. It's about infrastructure, and it's how we actually can make progress. When we start collaborating with each other. So competition, of course, drives speed. And we are talking every day nowadays, every day now about innovation and so on. But collaboration drives direction. So this is what I really feel deep inside. Without collaboration, we risk becoming very efficient at solving the wrong problems. So you become super expert in one thing. But if you don't collaborate, that's it.
Yeah, very, very true.
Yeah.
Yeah. Okay, so your work on extreme environments and astrobiology has implications on our understanding of climate change.
Yeah.
And at the same time, it helps us understand how life has evolved. So do you think going back to the beginning can make us prepared for the future? Could we predict what life on Earth would look like in the next 100 years, for example?
Yeah, it's a very good question as well. As I strongly believe going back to the beginning will prepare us to understand and for our future, because the beginning was very stressful in our planet, and we go into the same direction in a relatively short time. Early Earth was an extreme environment, right? Radiation, low oxygen, very different chemistry, and we had different microbes, and they evolved under these very stressful conditions. So they are used to those very, for us, from the human point of view, very stressful ecosystems. And they know how to deal with these. They have evolved solutions to deal with extremes. I mean, 3.5 billion years ago. So they are the experts, actually. And they doing this in silence, and we just start realizing and knowing better in the last few decades. So it's a long way to go. So when I study my stemophiles today, we are not only studying exceptions. I think we are studying strategies, core strategies of life. You know what I mean? It's something that really can help us to understand future scenarios, and we can start learning how to use this knowledge to tackle issues that we are facing right now and that we will be facing soon. And we need to open our eyes for those things because this is really happening now. In many ways, microbes have already experienced what we are now call extreme. Extreme weather, extreme desiccation, extreme drought, or extreme cold in some other places. And they are there, just happy, just paradise for them. And we need to learn with those microbes. But regarding your question, can we predict that, what life will look in 100 years?
Yes.
I think probably not when I think about specific species, but I think yes, when we can predict process, the process that will be happening in 100 years. So the species can change during this time and can evolve and can differentiate. But the process will be important, and we can understand systems and how the systems will respond to those stress conditions, and where resilience actually will come from, in the way that will evolve in this direction. Yeah. The future is the future for life is really writing in how we understand the past. That I think there is no other way, But not only about the species, but the process that will evolve and will happen in different ecosystems. I think so. Yeah. I don't know if it was answering your question. It was kind of a tough question because we don't have a crystal ball, but we can actually forecast what will happen in a near future or in a few decades from now.
I see.
Coming back to the concept of extremophiles, because we discussed about them quite extensively, I believe that one of the things we should also have in mind is the definition of that the definition of extreme presupposes the definition of normal. So there's a lot of work that has been focused on what we call extreme ecosystems, but we still lack a definition of normality. In the same way, when we talk for healthy microbiomes and humans,
Christina,
we cannot really define them.
This is a very important question and also a very tricky one, I think. We often talk about normal and health microbiomes, but as if they were like fixed states. But they are not. They are not like fixed states. They are completely changing, and I think this is pretty much context dependent. So there is no such thing like health and normal microbiome, and this depends on the context that we are talking about because they are not fixed. There is no, thing like this. In my, personal feeling, and I think one of the shifts in the field now is that we've been very focused on who is there instead of what they are doing. And for me, health is not a list of microbes. It's not a list of microbes. Is mainly a set of functions. And a health microbiome can be one that is functional, stable, and resilient, and able to maintain key processes, especially under stress. So this is why I think it's changing, because we try to, to put a stamp. Oh, this is a health microbiome, and of course we know some of the members of some microbes that are really linked or related to health. But it's difficult because when you think about this all day stamp, so always this will mean that is a health ecosystem or a health gut microbiome. But it's not really like this. I mean, if you have the process that are important to maintain health, and health mean could be for a human or could be for soil or a marine ecosystem. So this actually in the last, I think it's really linked to what they are doing there, more than who they are. That's my personal feeling.
Yeah, I agree. So I would like to go back to the extreme environments.
Yes, sure.
Okay, so based on your research, do you find common features or even challenges between different types of extreme environments?
Yeah.
In other words, are all extreme environments unique, or is there some kind of connection?
Yeah, I think this is also very, very interesting because we don't have a clear definition about, what is extreme. So this depends pretty much
Yeah.
of the, the kind of stress or the kind of chemical or the kind of physical stress that is there, and extreme for who or whom, it's. When we think about microbes and a lot of animals as well, and some plants as well, they actually can perform, they can not only survive, but they can thrive in conditions that for us will be super extreme. And they are there, just happy and doing their things, just normal life for them. So I think this is one of the most fascinating things that we see when we work in extreme environments. When we think about the human perspective, and they can actually look quite different. When I think about, they are quite unique. I mean, when I think about deserts, hydrothermal vents, polar systems, so they are different. They have their uniqueness at some particularities depending on the environment. But at the same time, if you look from the top, like from above, you can see that they actually have very similar constraints as well. So this is something that I'm studying right now in my lab. So these constraints of life, that means the big questions like energy limitation, the stress and chemical constraints.
Yeah, makes sense. Yeah.
Yeah, makes sense. Yeah, and the stress actually should be viewed as an evolutionary process as well, and not only something in the background. That's the kind of philosophy that we are implementing in my lab and in my team. And what we observe is that life responds using relatively limited toolbox when we look, with this perspective, with those lens. Usually rely on efficiency, metabolic flexibility, and of course, a lot of cooperation. So cooperation again, and not competition like most of people, and I include myself in this, package, used to think about, especially when you think about extreme environments that usually are so limited in resource. So we believe it, or there are a lot of people that still believe that it's really competition is the main driver. But actually now we are discovering a lot of collaboration, a lot of interactions between the microbes. And they can, so if you compete and if you are really a high competitor, you can perform well for a while. But when we start to build collaboration with some other colleagues there, they survive, basically almost forever, in very stressful conditions. So this is something that we need to learn as humans as well when we think about microbes. Yeah, definitely, yeah. So extreme environments, they look different when we think about this, but they speak the same biological language. That's, I think, one thing that I've been learning, I'm still learning during my life. So the diversity is huge, but underneath that, there is unity in strategies. So this is what, we've been, took a while to start to understand we all know that it's super complex, it's not that simple, but it's so beautiful when you start to dig deeper into those relations, connections that they can do, or they can perform in the environment. That is, wow, it's fascinating. I don't know if I answer your question, but yeah, that's what I think about this.
Yeah, unity and collaboration. Yeah. So I have another question that actually was a friend of mine sent me when I told him that we're gonna record the podcast, and the question is about your involvement in the Nabatean Traverse expedition. We read that this expedition is planned for September 2026, and it's going to travel from Jordan to Saudi Arabia, and it will be microbiologists, archaeologists, all kinds of specialists researching extreme environments. So can you tell us a bit more about that? What are you looking into?
Yeah, because we are facing our geopolitical constraint in the region, the expedition was postponed to next year. So I hope, by 2027 and in spring in this region here, so let's say by March 2027, we are actually planning to have the expedition. And this expedition will be amazing because we'll combine microbiology, space research. So there will be a lot of people that are working on space agencies also joining the expedition. And they actually will be trained by us in how to do sampling, in very harsh ecosystem, so that we'll be crossing, trekking, through the desert, from a beautiful region that we have here in South, especially in Saudi Arabia. When you think about Saudi Arabia, is in the north part of Saudi Arabia, and it used to be some thousands of years ago the Nabatean. There is a very ancient civilization from the region. This is brief before the Islam, before the countries that we have nowadays. So they had the Nabatean civilization. They built Petra in Jordan. Petra was the capital, but we have in Saudi Arabia, Hegra, in Alula region. There is to be the second biggest city of the Nabatean empire, and it's extremely beautiful, the place. It's amazing. And so you have ancient heritage, mums. You have a lot of very old stuff there. But we also have extreme microbes during the way, the pathway. And we have the top, future science when we think about the space connection, because some of the equipment or devices or sensors or material that we are planning to test during the tracking would be useful for the astronauts on Moon, or who knows, one day on Mars as well, So this is something that we are planning to do. And actually, it's interesting because we'll be following the ancient incense road. So it was a trade road that they used in the past. And they rode to bring incense from inside the countryside. And they actually jumped to Petra, and there they connected a little bit up, going to Syria, with the Silk Road, and now Ice Road. So it's a very unique, beautiful when you think about history in the heritage and all that stuff. So the idea is to connect the ancient, with the future, the space. We are working on the process, and actually we had this setback. I mean, we need to postpone the expedition, but actually, if we can see for the bright side, it's good because we have more time to organize even better and have more insightful ideas as well. So we are quite excited about this as well, this expedition as well.
No, it sounds amazing. It sounds going to be great. So before we wrap up, I would like to ask a forward-looking question. So where do you see the microbiome field going on in the next 5 to 10 years? Is there going to be any breakthrough? Are we going to have more questions than answers?
Yeah. In the next 5 to 10 years, the things, It's also very interesting and exciting question that challenged us to think about the future. I really think the next 5 to 10 years would be very, very exciting transition from where we are now and where we are going. So I think we are in a very beautiful, perfect momentum that everything is happening now. It's like some microbiologists like to say that we are now in one of our golden age of microbiology, because a lot of things is happening. We have more tools now that we didn't have a few years ago. Of course, we still have a long way to go, but we are in a momentum now that we are getting there, So there is still a lot of fundamental questions, of course. So we still don't know almost nothing about the huge microbial diversity that we have in our planet, about the huge amount of novel proteins or novel metabolic pathways that they have, or they can harbor. Of course, we don't know much about the potential new metabolisms that those microbes can contain, and we don't know much about the interactions that those microbes can perform or can have with each other. So it's still a long way to go, But at the same time, I think the field is reaching a certain level of maturity that we didn't have a few years ago. So now my perception, and I think most of my colleagues as well, is that we are really, starting like, wow, this is really what is happening. And we are moving from just observing microbiomes, but we are moving now to design, microbiomes as well, to modify microbiomes as well. We are learning the process, how to do this. And the microbiome field is entering in what I like to play with, or to say to my students, in its engineering phase, So we are now start to build collaboration, synthetic communities, microbial communities, or using interesting tools like CRISPR to try to modulate microbiomes as well, and try to have those microbiomes performing interesting functions for the benefit of ecosystem restoration or human health. And the real breakthrough, I think, will be when we can reliably, predict and also steer microbial ecosystems. When we be able to do this, will be like, wow, this is really a game changer. This will have, I think, huge implications for a lot of problems that we are facing now, like when I think about coral reef restoration, and now we can modulate and we can rely on the power of microbes, probiotics, to help the corals to cope with pollution or climate change. And this is also changing the way that we can see human health as well. So there are a lot of interesting research and things happening that is really moving the field now in a very fast pace. And of course, when you think about extreme environments, the same thing. Now it's becoming not a black box anymore. We are really learning how to leverage the power of those super, microbes that thrive in extreme environments. And they actually will teach us how to be able, to build human settlements and colonies. I don't like the word colonies when you think about humans, But anyways, but it will help us, to be in space one day, because we will need to rely on microbes. We will definitely need to include microbes into the equation. And so this is something that actually the space agencies and some other stakeholders, they now are really aware about this kind of need. So we are moving from understanding life to actively shaping it, shaping life. There is. I like to say to my students that, microbes, they have always been the real or the unseen engineers of our planet. And as we begin to understand, and harness their potential, we may unlock, I think, new ways to sustain life, not only in our planet on Earth, that we need a lot, and we will need a lot to have more sustainable approaches, but also beyond our planet, as we are moving now to new frontiers, Moon first and Mars later, and I mean, that's my feeling, really.
And who knows when? Yeah. Who knows what's next?
Exciting times ahead.
Yeah, exciting times with microbes. So we should hear them, and learn. Okay, so Professor Rosado, that's the end of our interview today. So thank you so much for sharing your insights with us, and we wish you good luck and success on your future expeditions. It's been an inspiring discussion. Thank you.
Thank you so much. Thank you very much.
So for our listeners, thank you for tuning in to our MVIF Conversations, the podcast. Our guest was Professor Alexandre Soares Rosado. Please remember to sign up for our free monthly virtual conference sessions. And until next time, stay curious, stay connected, and don't forget that microbes are everywhere. Thank you.
Thank you. Take care.
Thank you for listening to MVIF Conversations, the podcast. Until next time.